Hi guys, today we're going to learn about scientific notation. Scientific notation is when we write really big and really small numbers in a certain form. The format is always C times 10 to the n, where C is a number between 1 and 10, but not 10, meaning C could be like 1.2, 9.9, 3, but it can't be like 10.1 or 21.2 or anything like that. Notice how here it says standard form. This is the regular way you write the number. We can go ahead and skip product form and go straight to scientific notation. If we want to write a number in scientific notation, what I'm going to do is I'm going to skip this product form thing. And to write a number in scientific notation, one thing I want you to remember, let's scroll back up here, is that if you're doing positive exponents, you're dealing with numbers that are bigger than 1. And if you're doing negative exponents, you're dealing with numbers that are smaller than 1. I want you to memorize this. Okay? So, let's say I want to do 141,600,000. That's a ginormous number. I want to change that into scientific notation. That means I'm going to take my decimal, which is currently over here hiding, and I'm going to move it until I get a number between 1 and 10, but not 10. So not yet. That one's 141.6. That's still not between 1 and 10. 141.6, 14.16 here. 1.416. That's between 1 and 10, but not 10. I'm going to multiply that by 10 to the what power? Well, let's count how many loops we did. 1, 2, 3, 4, 5, 6, 7, 8 loops. We did 8 loops, and the original number is larger than 1, so that's 10 to the positive 8 exponent. Because positive exponents are for numbers bigger than 1. Okay? So now let's try this one. 0.022. I'm going to write that in scientific notation. So here's my decimal. I didn't have to bring it out of hiding. And I'm going to move it this time to the right, because if I move it to the left, I keep getting zeros and zeros and zeros. So move it to the right, and I'm going to go 1, 2. I'm going to stop right there because that's 2.2, and that's between 1 and 10, but not 10. If I went one more, that would be 22. That's too big. So 2.2 times 10 to the, how many loops did we do? Let's recount. We did 1, 2 loops, and last I checked, 0.022 is smaller than 1, so that's 2 loops, but it's got to be a negative exponent because negative exponents are for numbers smaller than 1. Okay? So you should pause this and try checkpoint 1 and 2. Okay, pause it. Now we're going to move on. Taking it out of scientific notation. Take it out of scientific notation, same thing. I need to take 4.1 and do 4 loops, but in which direction? Well, since it's a positive 4, I need to make a number larger than 1. So I'm going to loop to the right. Because if I loop to the left, it's going to make the number smaller than 1. So we don't want to loop to the left. We want to loop to the right. How many times? 4 times. 1, 2, 3, 4, 4, 1, 0, 0, 0. There's 41,000. That's this number in standard form. Why did I loop to the right? Because it's a positive exponent. It needs to be a number bigger than 1. Here's a negative exponent. That means 7.23 has got to be a number smaller than 1. If I loop to the right, it becomes 72, 723, too big. We got to loop to the left 6 times. 1, 2, 3, 4, 5, 6. Whoa, a lot of zeros. Did I do that correct? 7, 2, 3. There it would be in standard form. So now you should be able to do checkpoints 3 and 4. Okay. To order the numbers using scientific notation from least to greatest, I would take all the numbers out of scientific notation so that you can see which one's the biggest and which one's the smallest. So write 5.3 times 10 to the 5th in standard form. Or, I'm sorry, you can actually write this in scientific notation if you'd like. Since this one's already in scientific notation, let's keep that. That's all right. Let's write this one in scientific notation. So that's going to be, let me erase this. That's going to be 1, 2, 3, 4, 5. 5.2 times 10 to the 5th power. Okay. If you take a look at these in blue, they have matching powers. So since they have matching powers, let's compare, contrast them. Who do you think is going to be bigger, 5.3 or 5.2? 5.3 is going to be bigger. So 5.3 is the biggest. And we said least to greatest. So let's put the greatest on the bottom. Followed by 5.2 times 10 to the 5th. Why would 7.5 times 10 to the 4th be the smallest? This is least to greatest. This one would be the smallest because it only has 4 loops. And this one's going to get 5 loops. This one's going to get bigger. And this one's smaller. So this would be the smallest, followed by 5.2, followed by 5.3. You can always change them to standard. And then compare, contrast the numbers in standard form. You just have a lot of zeros if you did that. But you could if you wanted to. Or you can compare, contrast them this way. And you'll see these are the same. So this one's larger. 5.3 is larger. Followed by 5.2, who's smaller. And 7.5, even though 7.5 is bigger, it's to the 10 to the 4. It's times 10 to the 4th power. So it only has 4 loops, not 5. That should help you with those. Watch out for the negative exponents. You might want to change these to standard to compare contrast. I would, personally. I would change these to standard form first and then compare contrast the decimals because I see it better that way. And then last but not least is this example. Go ahead and copy that down while I read. The volume of 1 mole of oxygen atoms is about 1.736 times 10 to the negative 5 cubic meters. Find the volume of 1.5 times 10 to the 4 moles of oxygen atoms. They give you the formula because, you know, we're not in chemistry here. So here's the formula. 1 mole, that's this number. Number of moles, that's this number. And I can multiply in scientific notation by doing the commutative property. Take a look at this. Here's one scientific notation times another. And what I did was I commuted. I took the numbers and put them in their own parentheses and took the exponents and put them in their own parentheses. I multiplied these numbers. You feel free to use a calculator. And then I did product of powers here. Remember, for product of powers, you keep the base and you add the exponents, which leaves me with 2.604 times 10 to the negative 1. And that should help you complete 7 and 8. Please write down any questions on Post-it notes or on the side of your note-taking guide so that you can ask them in class. And also feel free to email me if you have any questions. Okay? See you guys soon.